We'd like to welcome everyone to our webinar. Thank you for joining us today. My name is Derek Needing of Razorleaf Corporation. I'll be serving as our host and MC for our webinar today. The topic we're going to be discussing is creating digital thread and IDEs to support digital engineering. So for those of you that are not familiar with us, Razorleaf is a global PLM consulting firm. So our job is to help companies leverage PLM and related technologies and put those in place to make their products better, to make their products faster, and to enable that digital thread. So as we talk about some of the concepts behind digital threads and IDEs, Razorleaf is the group of people that helps companies put those technologies in place. My name, as I mentioned, is Derek Needing. I'm the VP of Sales at Razorleaf, and I've been with Razorleaf for quite some time. I've had some roles on the services side, actually working in consulting, and now I work on the sales side of our organization. We're joined by my colleague, Jonathan Scott. Jonathan is the chief architect at Razorleaf Corporation. Jonathan has also been with Razorleaf for well over 20 years. And his role at Razorleaf is really about investigating emerging technologies and figuring out what our customers and clients need, what they're going to need, and then figuring out how the technologies and the services that we provide can put those technologies in place. We're honored to be joined as well by Peter Bilello from CIMdata. For those that are not familiar, CIMdata, of course, is the leader in PLM education, research, and management consulting. And so Peter's job is and CIMdata's job is to really be out there and figure out what's happening in the PLM world, what are the emerging trends, and how can they consult and direct their clients to take advantage of those. Peter is the president and chief executive officer of CIMdata. He's been in this industry for over 40 years. He's helped on the IT side, on the engineering and the product design side, helping people select and implement these technologies. One of the things that Peter spends the majority of his time doing today is about research. So whether it's gathering data or authoring papers, Peter's deep into the worldwide PLM market and trying to figure out where it's going and what technologies apply to where it's going. So with that, let's talk a little bit about what our agenda is today and what we intend to go through and discuss today. Jonathan, can you get us to the next slide, please? So I mentioned who is involved. You'll notice on the right-hand side of the screen in your GoToWebinar panel that there is a place to ask questions. So we've reserved some time at the end of the meeting to cover questions. If we don't have enough time to cover all of the questions, that's okay. We'll reach out to you individually with answers to your questions or start a dialogue to try to help answer those questions. So as we go through the webinar, we're going to take the questions at the end, but as you come up with those questions, please throw them in the panel. And then we'll gather those and cover those questions at the end. And so with that, let's turn the floor over to Peter to help us with an introduction to this topic.
Well, Derek, thank you very much. Really appreciate the opportunity, and thank you very much for the introduction. A little bit about the survey results that I'm going to go over. So one of the things that CIMdata does is we host and facilitate a number of different what we call action groups, and one of them is in the aerospace and defense community, made up of the largest, commercial and other organizations in aerospace and defense, wanting to know what do people think the digital thread is. So that's really what we're going to focus on, some of the results from that survey to try to understand what is the perception, what's currently, where the spend is currently, what people are focusing on currently, to see if there's any kind of natural way that people are moving, but also look at the kind of the status or the difficulties, challenges that industry's having when it comes to implementing or even understanding digital thread. Kind of the main message I would to share with you is to start with is there's a lot of definitions right now of what digital thread is, and that's kind of interesting, but it really kind of shows the start of the market and maybe the state of maturity or immaturity of the enablement for the digital thread. And from a product lifecycle management perspective, I would say that that's what we've been trying to do for decades. That is, manage the life cycle, from concept through life, and have bi-directional traceability. And that's certainly in some way what people describe the digital thread to be. The great thing is there is a great opportunity to really leverage connectivity across applications, across processes, across departments, and that's some of the things I'll show you as well. So let's take a first look at the first kind of a slide I'd like to share with you, and that's where are people spending money, basically? What are they currently implementing? What do they look to implement in the next or enable in the next 3 years or so? And then what do they expect to go implement after the first 3 years? And what you'll notice here is there's quite a bit of plans in the bigger picture of traceability. And that's that end-to-end connectivity into then systems engineering and other more life cycle approaches, not just from where we're at now, which is around data, requirements, design, electrical design, software design, and connecting the design aspects, but then moving into some of the near-term capabilities beyond that, like simulation, program management, some of the less traditional, I would say, PLM focuses, and then finally into the long term, again, broadening that out into manufacturing, into service, into operations. So we're kind of looking at the traditional way of implementation of processes, going from the concept development phase into the manufacturing phase and then into the service phase. So this is pretty much following what we would expect the typical implementation to be from a lifecycle perspective. So let's next take a look at what's going on around the value, considered to be the value footprint. Kind of currently, where is the focus being placed on? And where we see this is mostly implementations, and the use cases are kind of focused around, again, more traditional areas of lifecycle BOM management, manufacturing engineering. So again, kind of development. But if you look at where people are placing the importance on it, we see other things coming to play as well, like change impact analysis, certainly continue to put emphasis on manufacturing, but then design optimization, conceptual design traceability, and others. And what this leads to is kind of a overall perspective, is that there's a definite contrast between the high importance that is assigned to digital thread use cases and specific ones. I kind of pointed some of those out, but the current state of implementation, which tends to be much lower than the desired or the perceived requirement, which really indicates we're early again. We're in an immature phase, maybe entering, for some companies, maturing, but for the most part, immature. People are trying to figure out, what is it? How do I get my hands around it? And some of it may be the challenges, which I'll talk about in a minute. Let's go ahead to the next one and take a look at understanding what people are looking at. And you can go ahead and build this slide out. We're looking at future, what are the industry leaders are talking about here, where the investment is going. Certainly investment downstream, right? Production service, as I mentioned already, more emphasis on digitalization and the digital thread community that exists beyond the four walls of the organization, but out to customers, suppliers, partners, and so on, which helps companies really get control over the multiple aspects of their business and multiple development aspects, the model-based system engineering being a driver for supporting the interconnectivity that's needed between the different disciplines. And as we look, though, at that next stage, moving beyond traditional areas of engineering, basically, and development, things get more complex, but at the same time get more transformative. There's more value that can be established by broadening out what that digital thread is, because we don't talk about this a lot, but we won't talk in this survey a lot about the digital twin, but in order to have a digital representation of the product and or service throughout the life of a product, you have to have a thread that connects the information so that that digital twin and those representations that exist are always valid. And that's something that some people forget. And I always like to say that a digital twin without a digital thread is an orphan. So let's move on and talk about a little bit about what we see as the strategies for success. We look at and talk about these. Some people will have reported to us, these surveys, that we need to be able to provide the right interfaces between the applications that create, manage, use that information, that associate what we call product data artifacts, the attributes. Sometimes that could be even a search engine just kind of sitting on top of the information and providing that connectivity. For others, though, the key is association and traceability of dependencies between the artifacts. I would say that's a little bit more complex. There's a whole set of use cases there as well. The linkages could be around requirements, right? True traceability from concept. What is the market telling you? What are the different requirements, maybe regulatory requirements, customer requirements, just general market requirements, and how do I make sure that I'm delivering to that? So the connectivity of those requirements into how do I satisfy those requirements, and then how am I satisfying those requirements in the long term, which really requires an integrated approach, an integrated digital approach. And colleagues from Razorleaf will talk about that in more detail on how they're approaching that and how they're enabling their clients to support that digital connectivity and those digital environments that are needed to support the development of product and ultimately the full life cycle. So we'll think about these requirements and traceability. It's important also, of course, out in the field. If I'm going to make a change to something in the field, I have to know that it's still appropriate for purpose. And then some people are telling us, the current focus is more on, hey, I got to get my house in order first. It's about, the data governance, making sure that and this is important, and CM2 will say, clear, concise, and valid. I need my information to always be clear, concise, and valid, appropriate for use, because if I don't build my foundation correctly of information, then my environment, my digital environment and the information will always be in question. So what about let's talk a little bit more about strategies for success. So as you look at success, you've got to also look at what are the challenges. And there's unfortunately some challenges. I don't have one solution that's going to support a full digital thread. I think we just have to accept that. Again, colleagues from Razorleaf will talk about how they're approaching that and dealing with that and having their clients be successful, because there is interoperability issues. Not every solution is going to come from the same provider, same vendor, so that is an issue. There's complexity, even how you use different solutions within an organization, different extent of knowledge and so on. But how do we mitigate? So what are the mitigating factors, basically? Well, first one, not surprising, happens to be standards. One way to minimize the issue around interoperability is to make sure that you have standards that allow for data to be exchanged, or build out an environment, a connectivity environment, a digital environment that allows for that interchange of information. Management support is quite critical as well, getting people to understand that it doesn't come for free, but there's value though. So there is benefit, but you have to be able to spend money. So kind of an overall, I would say, a takeaway from this, we go is that the number one issue around interoperability aligns quite nicely, as I said, around interoperability and the need for standards for organizations. So happen to come out that way. It's of course very much related, and it's something that I always tell our clients, think about standards. There's a lot of them. The good news is there's a lot of standards in this area of digitalization, digital transformation. The problem is there's a lot of standards, and so there's a need for integration, and that's really key. And again, that will be echoed as the gentleman from Razorleaf Jonathan talks in just a little bit. So let's go on and talk about some of the comments that come up from around a solution technology perspective, and what are some of the key aspects of capabilities that are needed. First thing is enabling that traceability. There's value in having traceability of information so that you're always making sure that you're working with the right information, no matter where that is in your extended enterprise. Also understanding that digital thread, there's a value landscape, and it's distributed across and throughout the value chain, right? It's not just about typically an organization, certainly not about engineering only. It's about a set of distributed organizational capabilities, processes, technologies that have to be brought together in the right kind of digital environment. And oh, by the way, they might be multiple digital environments that are needed as well. Again, that will be talked about in a little bit in more detail. Proven technology solutions certainly exist. There's many of our clients and people that responded to the survey said, hey, we've been looking and working with, quote, leading solution providers. These are typically the software providers here that are kind of investing quite heavily, but also solution providers like Razorleaf that are providing services and technologies are also providing capabilities that are supporting this. And that's it's been echoed through by the people that have responded to the survey and others that we've talked to. And ultimately coming down to the foundational elements, as I already mentioned, information is the foundation of digital. Without information being, again, clear, concise, and valid, so captured, understood, managed, accessible, it's not just about can I search for it, but can I find it? And when I find that information, it's accurate. Do I have traceability? Usually bi-directional traceability, so that information is always understood in the right context. So that information foundation has to be then managed. So data governance is important. One of the things I'll just briefly mention, you get more information out on the web, our website and others, is we talk about, CIMdata talks about the critical dozen. These are 12 aspects of digital transformation are needed. And one of them is very important one is data governance. That's a critical aspect that a lot of companies forget about. They think, okay, I put the systems in, data will be governed. No, there's policies and procedures that are needed to support the data in a way so that you can enable the digital environment, you can enable the digital thread and digital twins and other aspects of that in digital environment. So let's go on and talk about for a little bit, or again, a bit more about those solutions and what solutions are people saying are part of this digital environment. What comes up front, you can see over 80% of the respondents said, well, PLM, PDM is included in that. And I would have to agree that kind of fundamental to digital transformation from a lifecycle perspective is the technologies we generally call, I would call product data management technologies. Some people may call them product lifecycle management technologies. To me, in CIMdata, PLM is a strategic business approach, which is enabled by processes and all types of technologies. PDM and the digital backbone that's needed can provide a lot of capabilities, but not all the capabilities by any means or any extent of the imagination, but it is certainly a core capability. Mechanical CAD was another one that came up. You can see about 75% mentioned that one. ERP, again, we're talking about life cycle here, so not just about product development, but through life, simulation analysis, office automation or applications and so on. So what about, we look at these technologies then and look at how they're used to link information. And we said, okay, well, we asked the question, what are being used to link it? Well, again, PLM, PDM comes up a lot. Some PDMs, I would argue, do a better job than others. There's still a need for additional capabilities. And again, Razorleaf are doing this, and you'll see this in some of the discussion that will follow. Some people are looking at ERP to do that. Quite frankly, I don't see much ERP in the ability to link solutions. They tend to be a platform of solutions already, tends to be custom applications built, but more specific focused applications actually are being built to connect information, link information. So ultimately we see kind of 3 tiers of solutions. Those tiers that are what we would say are the traditional solutions, long history. They've been trying to integrate with applications for some time. Then the second tier applications are data integration tools. Some of them been around for a long time, number of decades, and generally we talk about them as enterprise application integration technologies, and they continue to expand and evolve more so into more specialized technologies that combine data from multiple sources. They establish the linkages, they establish traceability, and you'll see hybrid approaches as well. And what I see in what Razorleaf is doing is some hybrid approaches that are providing value specific for their clients, but are configurable, scalable, and other things that people would look at to build out a digital environment that is, by the way, you can't just build out one, but you also can't build out one and think it's never going to change. So scalability, sustainability, all those things are important aspects as well in the approaches that you would want to look at. And oh, by the way, Razorleaf is approaching it that way as well. So it's good to see these things as they're coming together, and a great example of the work that Razorleaf is doing, and they'll talk about their approach to that in just a few minutes. So let's take a look at just a couple of things that kind of wrap my section up here as we finish out kind of that little bit discussion around people's view of the solutions capabilities and the alignment on it. There's certainly an attitude by industrial companies we survey and we talk to that there's good work going on in this area. Industry leaders are quite critical into supporting it and providing, the right kind of interactions, the right kind of interoperability, providing the right kind of flexibility. But there's still a lot of concerns, and I think rightly so, is around data model accessibility. This is something that's going to be really telling, I think, in the coming years with SaaS solutions. SaaS solutions, you're giving away the hosting of the solution, but potentially, so to speak, giving away your data or giving responsibility of housing your data on other people's servers. What's really important though with that, and I think that's all, by the way, can be handled quite well and can be very scalable, sustainable, and all the things that you need. One of the things though I would suggest people think about is, how do I get access to that data if I want to move on? So access to data is not just an integration perspective, necessity, which in this context is very important, but it's also a long-term sustainability issue as well that you have to consider. Some of the people say, we're neutral, we're waiting to see what's going on. We think some of the providers are going in the right direction. Some probably are not going in the right direction. Many people do say, the core people I work with, usually kind of the PDM, PLM people, are going in the right direction. Some are maybe fully capable, but there's still quite a bit of work to do. And some express some satisfaction, think there's good partnering going on in the space. Again, you want to look for a partner, by the way, someone that can help you build out environments across heterogeneous solutions as well. And then last thing I'd like to take a look at is just some kind of final comments that I would like to provide you with to think about is when we look at the concept of digital thread, as I mentioned up front, there's a lot of different views of what that is today. So it is kind of indicating we're at kind of an early cycle of from going from immature to maturing to mature. So lots of opportunities, but also lots of challenges. There are specialists within companies we came across in the survey that think that digital thread is this end-to-end connectivity and describe it fairly similar, but there's others that have a much broader definition. So work to do, partnering to take place to build out that common understanding or the understanding that's appropriate for your organization. There is definitely a lack of interoperability between vendors' tools, which means you need a partner that it can help you integrate across different tools that you have and that you will need moving forward. We know that standards are there, but there's a lot of different standards, and we have to build out environments that can deal with standards, but also can deal with integrations in a fast, scalable, and sustainable manner. So standards, I really believe in standards, but it's the right standards and building those out. But in the meantime, we still have to deal with a lot of bespoke solutions, but we still need a scalable solution and a way to approach building out these digital environments that allow us to do that in a cost-effective and valuable manner moving forward. And when we look at the current implementations, they're fairly modest, but people have some good views of what they want to do. They really want to connect the life cycle from an end-to-end perspective. The visions, we come across quite a number of visions of digital thread, digital transformation, in other words, that are wrapped around it. So there's definitely a lot of thinking going on in this space, and there's quite a bit of technology approaches and services that are going on as well. So hopefully this gives you kind of a perspective of digital thread, some of the things that we have found in this recent survey that we did. We think this is good for the industry, that people are thinking about it, they're starting to put effort behind it, and there are solutions that are supporting it. And again, I'll turn it over to Jonathan to talk more specifically about Razorleaf and some of their thinking around this area. And hopefully you'll take in a good appreciation of what can be done in your organization. So, and I'll hang around for questions at the end. Jonathan, over to you.
Thank you for that, Peter. Great. With that backdrop, I'd like to dive into my perspective on digital thread. So, Peter, your research aligns with what we've been seeing with our clients and partners, especially that the term digital thread means different things to everyone. And I think that's okay, because every industry is different and every business within an industry is different. And what really matters is the practical application of the digital thread concept for each organization or group who needs to build and use digital threads. Your message pointed out another important concept, which I think has two aspects to it. The concept I'm talking about is that PLM systems don't contain everything that today's digital product builders need. That's a little hard for me to say because I've spent a lot of time encouraging clients to put everything in their PLM systems, within reason, of course, but that's just it. I mean, I'll still advocate that organizations should put as much product data in their PLM as is reasonably possible, but be prepared to use more than just PLM to build their digital products. I think this is where IDEs become very relevant. Now first, I want to give credit to the defense industry for generating this concept. I won't dive into the history, but it makes sense that governments acquiring complex weapon systems would want more than just the physical product in today's world, right? They want to be involved in the development of that product, and they need the data generated during product development to sustain the physical item over the long term. So I'll get to defining an IDE in more detail in a minute, but I think IDEs are the answer to that need. a way to house the piece of digital thread which is relevant to a specific physical product. Naturally, that's going to have to tie into a larger enterprise digital thread, but an IDE is not meant to cover an entire enterprise. And in fact, it may cross the boundaries of multiple enterprises without encompassing any particular one of them. So enough talking around it. What exactly is an IDE? Well, there's some ambiguity to the acronym because it has at least two meanings. The history of the term IDE comes from computer science and coding. An integrated development environment was a suite of tools that software developers had traditionally used as standalone applications, right? Source code editors, compilers, and the like. Developers recognized the benefit of collecting all of the needed tools and tying them together to optimize their workflows during software development. And I've got a couple of physical analogies for this, right? An IDE is like a workshop. If you like woodworking, you'd recognize the value of having all of your tools in one place. The table saw over here, a workbench in the middle, a lumber rack nearby, that kind of thing. And if you like to work on cars, you would understand the value of having the right tools for the job organized in a way that makes sense, and also to have the appropriate materials and information at hand to work on a vehicle. It's a different kind of workshop, but nonetheless, same concept. So product developers are no different with an integrated digital environment, right? So not an IDE of integrated development environment, but integrated digital environment. It's a similar kind of workshop, one that makes it easier to develop digital products. So from Razorleaf's perspective, an IDE is an organized and self-contained workspace, tool set, and materials for digital product development. The Department of Defense has several more detailed descriptions. You could look out at, Air Force Material Command and other places, and other groups have their own definitions too, but the theme is pretty consistent. We're talking about collections of digital product tools which are fit for purpose. And although, I like the definition I just gave, we worked quite a bit on that. I'm very happy with it. I think a concrete example really helps convey the concept. So let me walk through one. So what specific types of things should we find in an IDE? Naturally, we'll have computing resources like workstations, laptops, tablets, mobile devices, servers, and cloud systems. We may also have specialized equipment, things like scanners to connect the paper world to digital, and very specific computing environments. Of course, we'll also have data. Unstructured data like notes, conversations, email, raw data, and meetings or decisions. We'll, of course, also have structured data like folders, tabular data, databases, reports, and documents. Then there's external data to consider as well. The specific nature of all of this data is clearer when we think about the next category of element we should find in an IDE. Tools and models, things like 3D models, ECAD tools, math models, systems models, materials databases, manufacturing tools, project models, financial models, phenomenological simulation, and maintenance tools. What ties this all together are the cross-domain processes which leverage the tools, data, and computing power to generate new information about the digital product. Now, the last key item we should find in an IDE is documentation for how to operate, use, and maintain the IDE. These are all important elements of an IDE, but let's see how they all come together. The foundation for an IDE is that computing layer, first thing we mentioned a moment ago. The elements here are likely to be different from IDE to IDE. And similarly, the data layer can be made up of unstructured data, structured data, and external data. This is another foundational layer of the IDE, and again, should be defined in alignment with the purpose of the IDE, right? No two data layers may look exactly alike. When we add in the tool layer, we can see how different domains might connect with different pieces of data and potentially different elements of the compute layer. It isn't simple to show graphically, but you can also imagine how these different domain slices might interact amongst themselves too. Which brings us to the next point. Processes are going to connect tools and models with the data, roles, and activities to achieve meaningful outcomes. Many of these processes will cross domains and data types, but these processes are what make the IDE truly useful. Tying this all together is the documentation and training needed for IDE stakeholders to use our digital workshop, as well as to maintain the environment. Now, that's a lot to consider, but I'd like to mention a few more important characteristics of IDEs to round out this concept. Digital product development efforts are as unique as the physical products they aim to create, right? You would use different tools to make a ship than you would to make, say, a hearing aid, just like you'd have different tools in your auto garage than in your wood shop. So IDEs are as unique as the digital products they build and support. So let's move from talking about this conceptual IDE shown here to a more specific application of the concept. Take this example of an IDE for an aircraft development program. It could include hundreds of modeling tools, thousands of people and partnerships, yet maybe only target a handful of customers, right? When you're making airplanes, there aren't that many buyers around. So it's a very specific purpose. Now, note that many of the domains, models, and tools shown in our conceptual IDE a minute ago aren't present because this IDE is purpose-built to serve an aircraft maker. The data layer is larger than the one we saw a minute ago. The compute layer is different. The processes are unique, and on and on. All right, so let's switch to looking at an IDE for developing a consumer electronic device. So now instead of targeting a handful of potential aircraft customers, we're targeting millions of consumers. We need different modeling tools. We need different resources and very different processes. Okay, one last example is an IDE that somebody might build if they're making this physical asset of a plant, right? This power plant builder might sell the engineering and construction of the plant and also sell a virtual twin of the plant provided as an IDE, right? So note again how different domains, processes, compute layer, documentation, et cetera, are needed to suit a different case. All right, let's go one step further and look at IDEs that might be interconnected within supply chains, right? In this view, we see the concept of shared and connected IDEs of different shapes, sizes, characteristics that all might exist in the supply chain of a vehicle maker, as an example. All right, so bringing the concept full circle to how we started the conversation today, let's look at how multiple IDEs within an organization might connect to the enterprise digital thread of that organization. In this diagram, we have two separate IDEs managed by the same company for two different purposes. Each IDE builds out its own digital thread relevant to the digital product activity taking place within that program or area, right? So like the IDE on the left seems focused on systems and financial models with heavy usage of external data and cloud plus mobile computing on that layer. So perhaps its purpose is proposal development for winning new business. Okay, but the IDE on the right looks like a more traditional environment with mechanical, manufacturing, project, and financial domains, and more internal data and diverse computing needs. You know, perhaps it's for executing a long-term build-to-print manufacturing contract. Even though the digital threads within each IDE are going to look different, the organization needs each one to be connected back to the enterprise digital thread in some way, you know, perhaps for enterprise financial modeling or intellectual property provenance, right? So let's have one last scenario for IDEs that could feel familiar to some of you in the audience. If you've operated in the supply chain for large OEMs or otherwise had to keep up with the technology demands of a trading partner, you'll recognize the need to maintain multiple concurrent environments with different versions of tools, standards, et cetera, so that you can work with your trading partners, right? So in this case, these IDEs look very similar, but yet they are also very different. The IDE on the left is for a retired program, right? But maybe the environment needs to be kept around for spare parts or legal compliance or something. The IDE in the middle is for an active program, which is starting to sundown, but it's still very active. The IDE on the right is for a new program that's just ramping up to full volume, and it's leveraging the latest software tools and data standards of that OEM. So the connection to the enterprise digital thread on the bottom raises lots of questions about what data to maintain at the enterprise level, at what version or format of the tools. And there's no simple answer to these questions, but it is yet another, well, hold on, my slides are moving on me accidentally there, sorry. It's yet another perspective on this concept of an IDE. So there's a lot to consider here, but I want to bring this back to the purpose of an IDE and how you might get your hands on one. So I gave you Razorleaf's definition for an IDE earlier, but perhaps a quick way to think of an IDE really is just to see it as a workshop for making digital products. And having heard my perspective on IDEs over the last few minutes, I hope I've piqued your interest and raised some questions in your mind about, how can I get an IDE? Hopefully that's one of the questions you're thinking. And I'll propose you cannot buy an IDE from a single vendor today, just like Peter talked about, but that you need to build one, right? So from Razorleaf's experience, one of the key challenges for digital product projects is integration, how to integrate the tools, data, and computing resources needed to optimize the desired processes. So let's take a moment on that topic of integration, because I think it's fundamental to an integrated digital environment. And I think integration means multiple things in the context of an IDE. For one, it means tying all of the right data into the environment in formats and interfaces which are digital and fit for use. For example, you might need to scan paper to make it digital, or you may need to load or connect files from an external system. Part of populating your data may be in how you structure it or model it also. So you may be integrating data models as part of this activity. Another integration need is one that many PLM users are already familiar with: managing data. You want to integrate design authoring tools to a management system like PDM, ALM, PLM, etc., to expose and manage their data elements and relationships. This is really the critical way that you build and strengthen your digital thread. And speaking of building out the digital thread, another key type of IDE integration is connecting systems like PLM, MES, ALM, etc. So coming back to the idea of building an IDE, what does that look like? So I propose that the first step to building an IDE, after knowing why you need one, like what's the purpose of it, what function does it serve for you, is to define requirements and select the components needed to provide the required capabilities. So if you know why you need it, what you're going to use it for, then you can understand those requirements, and you can pick out the things that you're going to need, like CAD tools, like project management tools, and similar. This might also include systems, not just point tools or applications. Systems to help manage BOMs, requirements, or other relevant data, things like PLM or ALM. With meaningful progress on that first step, then you can start the second activity to begin developing the specific processes you need to leverage the tool set to satisfy those defined requirements. So for example, consider processes like design reviews or engineering release. As these processes start to take shape on the tools that you picked, it's time to close gaps between the tools and systems and integrate where needed, right? Consider how the systems already in place might manage the process, like PLM could manage that release process I mentioned. But recognize that some end-to-end processes are going to require data connected with multiple systems like PLM, ALM, and ERP, and that data may cross functional boundaries. Another important thing to have defined during this step is a DevSecOps model for managing all of the changes to your IDE needed to support these optimized processes, right? This integration step, doing step 3 here, may cause a return to some earlier steps, right? When you realize, oh, well, I'm missing a tool, or there's a piece of the process that needs to be changed, that kind of thing. And there can be significant overlap as these first 3 steps are being completed. But as the IDE design begins to stabilize, you're ready to move on to step 4, when you can populate the environment with data and models. Now, this may require additional iteration, right? Because to finalize all the preceding steps, often you find that the theoretical plans for processes and data management don't align perfectly with the real world data when it starts being loaded. So the last thing I want to add is not actually the last step though. Throughout the building process, you should document the IDE and its evolving processes and provide training to stakeholders at each major step along the way. By doing this activity continuously and simultaneously, you'll maintain up-to-date documentation that can be used by new stakeholders to leverage the IDE in an ongoing way, which is really the best way to keep the environment vital and active and alive. So for a moment, consider the alternative to purposefully building an IDE like this, right? What's the opposite? Have you ever had to struggle through a project without having the right tools and resources? You know, kind of imagine the world's worst workshop where, you know, some tools are mounted to the floor and awkward to work with, and other tools are out of reach up on a shelf, and materials, you know, are too big or too small to fit the available tools. Or, you know, think back to that time where you tried to use a screwdriver like it was a chisel and thought there's got to be a better way. These are the problems of a non-integrated environment, right? So consider these concepts as your organization is planning its digital thread strategy. Will you try to build a one-size-fits-all enterprise digital thread, maybe even one that not everybody agrees on what that means? Or will you architect a collection of purpose-built IDEs, which can grow the focused digital thread needed by that particular initiative or program? And while you're pondering that, I'd like to wrap up the presentation today with some takeaways that I feel represent Peter's message and my own. So, reaching back to CIMdata's research, the first takeaway is there is no universal digital thread. Although there's a shared understanding of the digital thread concept, experts and practitioners struggle to offer a consistent, detailed description of a digital thread because organizations need very different things from their digital threads. Another takeaway is that we're very early on in the evolution of digital threads and how people will build them out. Peter noted from the research that the huge gap between assigned importance of digital thread use cases and organizations' current levels of implementation in those areas. And I hope that you also take away from today's discussion that program-specific digital threads are not mutually exclusive of an enterprise digital thread, and each may have their own value to an organization. On the topic of integrated digital environments, I hope you will agree with my definition of an IDE as an organized and self-contained workspace, toolset, and materials for digital product development. And lastly, I hope you will remember that Razorleaf builds IDEs. Our DNA as an organization is rooted in implementations of systems to manage digital product definition. And we've had a rich history of integrating and migrating data, tools, and systems in this space for more than 20 years. So if you find yourself considering building an IDE, I hope you'll reach out to us for a conversation in case we can help. So with that, I'd like to turn it back over to you, Derek, to see what questions we might have from today's presentation.
All right, thank you, Jonathan. Thank you, Peter. That was very interesting information. We do have quite a few questions. If you do have a question and you haven't asked it yet, feel free to put that in the chat window and we'll get to that. So I'm going to start with what seems to me to be one of the more interesting questions we've got here. And Peter, I've got to imagine you've stayed up at night thinking about this question. Don't forget to unmute yourself to answer, by the way. So what role do you see AI will play in helping to build the digital thread? So, Peter, what do you think?
Yeah, that's a very good question, and one that we'd have to just guess at this point for the most part. But you think about, there's different aspects of AI to begin with, right? Most people talk about machine learning. Machine learning, there's definitely some applications already being seen in understanding input of data and then being able to look at, you know, what's going to happen next based on that data and based on history, right, of looking at it over and over again, which helps build out an understanding from the digital thread perspective. But I think you get into predictive analytics, you get into other things, but AI becomes an enabler of understanding the data not really building. When I think of building the thread, I think about the connectivity of information, of processes and technologies. I don't see AI doing that, but I do see it enabling the digital thread and the value, gaining additional value from what that information is that is being, created, managed, understood on that digital thread to create better insight, quicker insight, better support of product, better feedback into engineering, closing the loop from the field. So I think AI has a huge application in many different ways around the enablement of the digital thread, with a focus on primarily on the information and the data, and providing more value and insight into that information.
Yeah, I like that, because really isn't that the point of the digital thread, is to take the data and be able to predict, to understand what it means, to look at a couple different digital twins and compare them and see what that means. And I think you're right, that's where AI is going to have an impact.
Yeah, I think
let me jump.
I agree.
I'm sorry, go ahead, Peter, finish the
Well, I
thought.
just said I agree, and that ultimately a thread is for a purpose. So the purpose is to be enable things to be done quicker, better, cheaper, and so on. But at the core, and I said this, and certainly survey echoes this as well, and you guys have echoed this, is data is at the core, and anywhere we can apply AI, it's going to be able to hopefully help us make better decisions more quickly. So providing that insight.
Yeah, I'd like to add on top of that, if I could, Peter. I think that's really one of the key points, is not necessarily that AI will help us build digital threads, but that digital threads will be really key for how much value we can get from AI, right? That the digital thread is the data that those artificial intelligences will need to help us predict things, because the richer that data set, the stronger the ties between the data, the better the outcomes will be.
I agree.
So let me move on to another question. And guys, I'm going to take a stab at answering this, but Jonathan, I suspect you'll have some comments as well. The question was, to visualize digital threads, do companies create unified information models? I feel that along with the digital thread and twins, we need UIM also. And I think from our experience, we have seen companies do that. Typically in the A&D space, we work with a large shipbuilder who, before they put any systems or processes in place, they build what we call the canonical data model, or a schema of how all of the data should be stored. Therefore, we knew how all of the data connected. So we have seen that. However, back to Peter's point earlier about the lack of interoperability, we've also seen that while that would be nice, that's not always possible. And so oftentimes, to build the digital thread or digital twin, you need to be prepared to connect systems together that do not have standards, and they don't run on standards. In fact, I was having a nice back and forth chat with Robert in the question panel, and one of the points he mentioned, Robert works in the military space as well. One of the points he mentioned was that there are parts of the product design and maintenance that are very well defined, particularly through MIL standards, ASME or ISO standards. But then you get into like some of the product support components, and they're not very well defined. And so, how do you create a unified information model when you know exactly what you need for product design, but it's up for discussion and debate on what you need for product support? And so that's what we've seen, is that, yeah, ideally, yes, a unified schema is ideal. In the real world, can you get there? We've seen challenges. Jonathan, any comments on that?
I agree, Derek. I think that the flexibility of that integration layer is what helps you navigate all that, right? If you can't necessarily have a unified information model if you've got a heterogeneous environment, but can you map it, right? Can you map what tool providers are giving you in their data models and their information models to some kind of standard ontology that maybe you have within your organization, or maybe really a truly standard ontology? But I think that's the trick, is can you map, can you transform, rather than try and really unify everything.
Good. How about this question? How do you see digital transformation, the changing of business processes, and new digital technologies? IDE. Jonathan or Peter, either one want to jump
I
in?
didn't hear the last part of that, Derek. You said, could you
How
just
do we
repeat
see
the end of that?
digital transformation enabling the IDE? So as
Right.
people are putting new business processes and utilizing new technologies, how is that going to help as they try to build out these IDEs?
So I'm going to answer it a little bit in the reverse. I think it's actually the reverse, that the concept of IDEs can help with business transformation, because the idea of having these, I'll say, I don't want to say standalone because they're not entirely standalone, but they're fit for purpose and purpose built environments for working on a certain project, right? And which is what is going to allow you to sort of fork your enterprise processes potentially to say, look, over in this IDE, here's how we're going to behave. And that can be transformational, right? I'm going to operate my business in a new way within that IDE for that project or for that program. That lets us try something new in a bit of a sandbox, right? And then evolve that for the next program and the next program. Now, we have to pay attention to whatever the enterprise still needs, though. We need an enterprise digital thread. There's value to that. You have to figure out what that is and what you need to keep at that more stable layer. But this is a way to experiment and evolve with IDEs while still maintaining that stability of the enterprise. So I see it as a concept to help enable business transformation with lower risk.
I'll add to that. I fully agree with everything you said. I'll add to it is transformation is about change, right? It's a changing processes, technologies, organizational structures, and really all three are what you're looking to transform over time. If I put a new technology in and don't change the process, probably not going to actually have any benefits. If I don't educate my people, don't change their skills, digital skills transformation is quite important as well. So yeah, it's not one or the other. It's about evolution. And sometimes revolution, but usually evolution is transforming in multiple dimensions to change the way you work. Now, some may be major transformations, like I'm going to move from selling a product to product as a service. Well, enable that, the digital thread, for example, becomes very incredibly important. These digital integrated digital environments become incredibly important. So they become enablers, but they're part of the transformation. So I would just kind of leave it with, digital transformation isn't just about digital or technology, but it's about people and processes, or organizations and processes, just as much as implementation of digital capabilities.
Yeah, I want to include a comment from my friend Robert that I've been chatting with on the questions pane as well, because he seems to agree with this also. I mean, one of the points he made, which I think is important, is that the IDE is not static. The IDE changes and grows in capabilities over time. So as we continue to evolve and know more about what we're looking for, the IDE changes, the IDE grows. So those digital transformation technologies, they will impact the IDE, and the IDE of today is not the IDE of tomorrow. It will have new and different things in it in the future.
Mm-hmm.
So I'm going to ask, we have time for one last question, but I think we have two questions that are somewhat related. So I'm going to try to put them together, and hopefully the questioner had the same intent as I believe they did. So the question is, are you suggesting that a company needs to deploy multiple PLM systems if they're going to have multiple IDEs? And I think that question is related to this question here, which is, there seems to be something missing from your IDE definition, and that's the scale of the application. Have you been speaking about product IDEs, or enterprise IDEs, or community IDEs, or assembly component IDEs? I think those are kind of related. So Jonathan, you want to take a stab at that?
Yeah, I do. And I think it's a great question, right? And I'll say, with what I presented about IDEs today, I don't mean to imply, to the first part of what you asked, Eric, I don't mean to imply that you need multiple PDM systems or PLM systems, or multiples of any of these systems. It may be that one system is just fine, and that perhaps you segment it by IDE. And maybe you configure those different areas of one PLM system in slightly different ways to support the different needs or purposes of each of those IDEs. Or maybe not. Maybe it's one PLM that's useful for all of them. The point, though, is that when you go to look at an integrated digital environment, you're thinking about its purpose first and its requirements, and then bringing in the tools and the processes and other things to support that, rather than saying, okay, well, we have an enterprise PLM system and it was really tough to put it in, and we've got it in place, and so now everybody use it. Use it the way it is. So maybe there's a place for multiple PDM or PLM tools, or multiple instances of your PLM tool, or any number of versions. I don't mean to prescribe that. So it could be, but I'm not trying to imply that that's what it has to be. To the second part of the question, really what I was speaking of was program level IDEs, right? So some big activity, some multi-month, multi-year type of activity that requires this level of integrated digital environment, right? I don't think you're setting up IDEs, because there's a fair amount involved in setting them up and turning them on. You're not doing that, every couple of weeks or every couple of months for some new project, or for a new, assembly component level, that kind of thing. So it has to be significant at this point, because the cost of doing it is significant. But I think it's all about the purpose, right? What you have in mind, and you have to size it and architect it right based on what you need.
Well, and Jonathan, wouldn't it be fair also to say, I mean, that question about, is it a product ID, is it an enterprise ID? I mean, some of that also is dictated by the product, right? I mean, your hearing aid versus battleship analogy. I mean, in the hearing aid company, it may be the product IDE may be the enterprise IDE, because all of our products are very similar and they can leverage the same IDE. But the company making battleships or jet engines has program level IDEs. Is that fair?
That's exactly right, right? And it comes back to that purpose, right? You're not going to need the same set of tools and data and compute power and all those things to make a hearing aid as you do to make a battleship. And if you've got diverse product lines or different product life cycles, these are all good reasons why you might differentiate, or you might group them together and share.
Perfect. Well, I think we're out of time for questions. There were a few other questions, and we'll get back to you individually via email. Jonathan, you want to pop up that last slide, and I'll offer a couple closing remarks. So we appreciate everyone attending. Well, I guess there is no last slide, so I'll just take it from there. Thanks everyone for attending. We have recorded this webinar, and we will send it out to all of the attendees. I wanted to announce that we have a podcast series that's launching here in a couple weeks. It's called Stay Sharp with Razorleaf, and so we're going to be talking about these concepts. And we're going to be talking about in kind of an informal and in very informational way, how are we seeing people leverage PLM, digital threads, digital twin, IDEs. We're going to be talking to people from Razorleaf, external people like Peter, and so we'd like you to join us at that for those webinars, or I'm sorry, those podcasts. It'll be available on whatever format that you typically consume podcasts on, and we'd like you to get involved in that, ask us questions, throw us suggestions on what you'd like us to talk about, and we would be happy to include that. So once again, on behalf of Jonathan from Razorleaf and Peter from CIMdata, thank you for attending, and we hope you found this beneficial, and please don't hesitate to reach out to us if you have any questions or any comments on the webinar. Thank you.